So welcome everyone. Nice to have you here for the workshop Let's Write a Haskell Language Server plugin by Pepe Iborra. This workshop will be recorded, so if you do not want to be on the recording, please disable your video and audio. If you have any questions during the workshop, feel free to ask them immediately in voice in the Slack channel or in the Zoom chat. They will be answered immediately. Also, we have a slight change. So if you are programming along, you'd want to use the MuniHac branch and not the head branch. Yeah, so without further ado, let's introduce our host. Your speaker today is Pepe Iborra, one of the top GHCIDE IDE and Haskell Language Server contributors. And in this session, he will show you how to write a Haskell Language Server plugin from scratch. Have fun with that. The first question towards you guys would be if you have used the Haskell Language Server before. For this, you can vote in Slack, and we'll check it out later. So, up to you, Pepe. You're still muted.
Cool. Thank you, Vanessa. Thank you for having me. And thank you, everyone, for joining. And I hope this will be a useful use of your time. So I wanted to ask how many people are using Haskell Language Server or GHCIDE, because, well, I hope everyone is as excited as I am that we finally have a good Haskell IDE that is written in Haskell, that works with pretty much any editor out there, and that has lots of hacking potential. So my hope is that by the end of this workshop, you will have the tools or the knowledge needed to create your own Haskell Language Server plugins or to contribute to existing ones. So I prepared some slides just to provide some background before we start coding. So Haskell Language Server is a language server. It's an LSP server, a language server protocol server, and LSP is a kind of a clever solution to the IDE problem, which is that every IDE for a programming language P is doomed to fail unless it is written in P itself, because otherwise there will be no the contributors will be discouraged to collaborate and to write code for it and to maintain it. We have seen examples of that in the Haskell community many times over the years. On the other hand, every IDE is doomed to fail unless it has a strong financial backing, because IDEs are very expensive to develop, or in particular editors are very expensive to develop. And again, we have seen some examples of that in the Haskell community. So if we put those two together, it's like every programming language that lacks financial backing is doomed to lack an IDE, and a programming language without an IDE has a harder time to being successful and being adopted by programmers at large. So LSP fixes this problem by decoupling the editor part of an IDE from the language analysis capabilities. So it divides these, or it separates these two concerns using the LSP protocol, where which is a client-server solution, a client-server protocol, where the client is the text editor and the server is the language analyzer. So it's a very simple protocol. It's a request response or main request response with a JSON transport. It has an informal spec. The spec covers only the messages. It doesn't tell you how to implement the client or how to implement the server. I think people have managed to work with this basic spec quite happily. So nowadays we have LSP clients for pretty much every editor out there, at least the most widespread ones. And the server can be implemented in a separate language, in a completely independent component. And then they both communicate through a pipe or through a handle using JSON. So to date, I think Haskell has at least 4 LSP servers, including GHCIDE and the Haskell Language Server. And this solution works quite well. The only compromise that LSP makes is to restrict itself to a set of well-known IDE abstractions like completions, diagnostics, quick fixes, and so on. So if your language fits this kind of use cases, then LSP is going to work very well. If you have a programming language that doesn't fit this set of use cases, then it's probably going to be much harder to develop an LSP server for it. But in the case of Haskell, it's a good fit. And speaking of that, GHCIDE is a Haskell LSP server, which is written in Haskell, and it's built on top of GHC. It really sees itself as a library for writing Haskell IDEs, which happens to bundle an LSP server. And it was originally created by a company called Digital Asset for their custom language DAML, blockchain language. They open sourced GHCIDE after MuniHac 2019, and recently they donated the project to the Haskell community. So it's now fully in the hands of Haskell.org. And what makes GHCIDE special is that it has a very opinionated architecture built on top of a build system that drives a dependency graph where the nodes are intermediate analysis, like the parse tree of a module or the type checking artifacts of a module. And these nodes get dirtied in response to LSP notifications that communicate user events like edits or file opening or file closing, etc. So the benefit of this architecture is that GHCIDE code is quite declarative, because one can say, I want the type checking artifacts for this module, and it's not necessary to say how those type checking artifacts are going to be computed, where they're going to come from, where's the source code for this module, or whether they're going to be computed in parallel or sequentially, or whether they're going to be cached or shared, because the build graph takes care of all that. So in a way, it provides a modular performance or a modular language for defining computations that require IDE analysis. It also makes GHCIDE quite memory hungry, because this dependency graph is fully cached in memory. But that's a small price to pay. And it might get better in the future once GHCIDE implements things like garbage collection or a database in disk to store all these intermediate results. And it's fair to say that GHCIDE builds on top of many other community efforts, like Shake. Shake is a Haskell build system created by Neil Mitchell, and you can go and read a lot of research papers about it. GHCIDE allows to define new Shake build rules that extend the dependency graph, just like you do in a Shake program. And this is one of the 2 extension points provided by GHCIDE. The other projects that GHCIDE builds on are HiBios, which takes care of interfacing with your project build system like Cabal or Stack, or if you have a custom build system like Hadrian for EHC or any other. HiBios allows to interface GHCIDE with your project build system and to extract all the GHC flags and settings that are required to build to load your modules in GHC. And then there's also Haskell LSP, which is the LSP protocol implementation for Haskell, which was part of originally of Haskell IDE engine, or was created for Haskell IDE engine, and provides the second extension point for GHCIDE, which is this set of LSP handlers, which are the handlers for handling LSP messages, notifications, or requests. The only problem is that the LSP handler's extension point in GHCIDE is not compositional. So it is not possible to combine existing handlers with new handlers. The handler's extension point is defined in a side-effective manner that prevents the composition of two handlers. So this is actually the problem that Haskell Language Server solves. So let's move on to that now. So Haskell Language Server is an LSP server for Haskell as well. It's fully written in Haskell as well. It's a very young project. It only started this year in January, I think, in the Bristol Hackathon, right before COVID put the entire world in lockdown. And it's the result of the GHCIDE and the Haskell IDE engine teams joining efforts. So where GHCIDE sees itself as a building block, HLS sees itself as a batteries included integration point for Haskell tools. So the idea is to have as many plugins as possible, integrating as many tools as possible, and then allow users to customize their experience by selecting which plugins they want to use and which plugins they don't want to use. So in that sense, for instance, currently Haskell Language Server has 4 or 5 plugins for formatting code, and the user can pick which one of these formatters they want to apply. So architecturally, HLS is very simple. It's just a very small plugin model, plugin abstraction that encodes the most common LSP patterns. So it covers like the 80% or maybe the 90% of the LSP use cases or interactions out there. So this reduces the surface that plugin developer needs to know about massively, and it hides most of the complexity. And this is only possible thanks to all the projects that it builds on top of, including GHCIDE, because that's basically what Haskell Language Server is. It's a thin wrapper around the GHCIDE. And the other thing that Haskell Language Server is a VSCode extension that can download precompiled binaries by automatically detecting your GHC version and downloading the binaries for it. So in that way, it solves the installation problem, at least for Visual Studio Code, which is a big deal. So let's move on now to the plan for this workshop. So the workshop is based on a tutorial that I wrote a couple of weeks ago. The idea is to follow that tutorial initially, and then take it a couple of steps further.
Sorry, just a quick question from the Slack channel. How does the configuration of which plugins to use work? From Andres Leu.
That's a very good question. So ideally, you would want to select the plugins that are going to be linked with Haskell Language Server. So that's currently not possible. There's no dynamic linking support, and I don't think there's any plans to do that. So the second best option would be to select which plugins you want to enable and which plugins you want to disable. And I think that there are plans for that. That would be great. But at the moment, that's not available. So I think at the moment, there's ad hoc support for selecting which completion provider to use. And that's all for now. Does that answer the question? Okay, I'll take that as a yes.
Yes.
Okay, so back to the task. Yeah, so we're going to follow the tutorial initially, and we're going to take it a couple of steps further. The goal in the tutorial is to write a plugin to help work with imports that lack an explicit import list. And we want to do that by using code lenses to display the import list on every import statement that lacks one, by using commands to allow the user to rewrite the import to add the explicit import list on click. And finally, and this is the extension, if there is at least one import statement that lacks an import list, then we want to show a code action with the title make all imports explicit that fixes all the import statements at once. There are other potential extensions that we can tackle if there is time. So one of these would be to change the UI to use hover instead of lenses to show the import lists. I don't like that so much because I want to be able to see the imports lists at a glance, all of them, without having to use my mouse to look for, because usually when you're looking at the import lists, you're looking for a specific identifier, you want to see what it's coming from. And the hover UI does not give you that. But we could explore it and maybe use the hover UI to complement the code lenses UI in some cases. So we can discuss that once we finish with this program, or we could do anything else, and we could use the time for some collaborative hacking if people are interested, or something like that. There's plenty of time for questions, so please feel free to ask and interrupt at any time. And yeah, well, let's get started. Oh, you can ask questions in Slack, but you can also ask questions in Zoom if you are in the call. Okay, so let me switch to Visual Studio. Here we are. So I want to go through the setup, even though I suspect most people have already done that, but just to make sure, so it shouldn't take too long. I've already cloned the project into the MuniHac folder, and I have edited the shell.next file to select GHCIDE 8.10 instead of the default version. And one more thing I want to do is I want to copy my Cabal project local file to the MuniHac folder. There's nothing special in that file, but I'll just cut it. So it's mainly this shared true and executable dynamic true. This is useful because we're going to be rebuilding the binary several times, and this cuts the linking times, which is a big chunk of the time it takes. So that's good. Now let's open an next shell and see that we can build. Right, so I forgot to clone the submodules. Okay, and in the meantime, I'm going to tell Visual Studio Code to open this folder. And reload, and let's see if this works. Okay, so the next thing to do is to, once we have built the project, we want to tell Visual Studio Code or your IDE to be using the same binaries that we're building. So we're not going to use the automatically downloaded ones. This is so that we can quickly test the changes that we are making just by reloading the plugin.
Oh, we have a question here. Do you need to install Nix to work on Haskell Language Server plugins?
No, not at all. So there is no need to install Nix. All you need to have is a working GHC installation and either Stack or Cabal. I happen to use Nix, but that's not needed.
Okay, thank you.
So as soon as the build completes, we're going to enter the executable path here. So let's wait a second for that. In the meantime, we can start looking at the plugin model because we're going to need to define a new plugin. So that's in file HS plugin API, source IDE types. And this is basically the thing that we need to provide, a plugin descriptor. So what's in a plugin descriptor? If you've read the tutorial, you already have an idea. A plugin descriptor is basically a set of providers, a set of rules for Shake, for GHCIDE, and a set of plugin commands or command handlers, really. So what are these things? The rules allow us to extend the set of build rules, and most of plugins do not need to create any new rules. We will be creating some rules in the second part of the workshop when we add a code actions. We will see why or in which situations one will need to create new rules.
Can I ask something?
Yeah.
Yeah. So am I correct in assuming, even if I'm jumping ahead now, that if you want the plugin to maintain its own state, then you will need rules? Or
yes, that's exactly the case. So when we add a code action provider, we will have two providers in the same plugin, a code action provider and a code length provider. And we will want to share or reuse some computations between these two plugins or two providers, sorry, which is the set of minimal imports. We don't want to compute the set of minimal imports twice on every edit. And this is what rules allow us to do. Not only can we share a state between two providers in the same plugin, we can also share a state between different plugins because the build graph is shared by all the plugins in the session.
yeah, thank you.
And if you want to have a thought about why things are done this way, I mean, it's very simple. Just imagine how things are going to work at runtime. The LSP client is going to be sending us messages asking us for different things, like give me the code actions for this line or give me the code lengths for this file. And these requests are going to come at different times, but they're going to be possibly overlapping, and they're going to reference different versions of the same source file. So trying to keep some shared state manually in that kind of situation would be really tricky and really involved and probably not compositional across plugins. So having a build graph or a dependency graph that takes care of that for us is a huge benefit.
Can I ask another question?
Yes.
Yeah. Can you describe like what the difference would be between the providers and the commands?
Okay. So yeah, let me do that. But before I do that, let me copy the executable path, because otherwise I will forget, and then things won't work. Okay, so that's done. we can go back to the plugin model. So providers are providers implement one of the various request response contracts defined by the language server protocol. So what are these contracts? The LSP client is going to ask the server for information of a certain type and give me all the completions for this text in position 1020 in this file, or give me all the quick fixes for the diagnostics D1 and D2 in file B. And this is well defined in the LSP protocol, what the server should return and what's the format for returning that. So so Haskell Language Server defines these abstractions that implement those contracts. And usually when we see the actual types behind these synonyms, they are functions that take some inputs depending on the type of provider, and they produce a list of things. Okay, a list of completions, a list of code lengths, a list of code actions, etc. Now, commands are another abstraction provided by the LSP specification, which is much more kind of free form. So the client doesn't. The client asks the server to perform some command, and then it identifies the command using a specific ID that the server has told it previously. So the server will inform the client about what commands it can do, and some of these code actions or code lengths will reference one of these commands. So once the user wants to actually execute the action, the client tells the server, okay, I want to execute that command that you told me before now. And then commands can do pretty much anything. So the server can use a number of LSP kind of interaction patterns to perform changes in a file, or to interact with the user via messages, or even ask the users, give the user choices. Or log things, or so a command handler basically is a side effect.
So something like performing case splitting would be a command, or?
Yeah, so the actual action of editing the file to split a case pattern, that would be the edit would be the command. So the command would say, hey, client, make this edit for me. And it will send a diff.
Yeah, okay.
Cool, thank you.
Okay, so we were doing the setup. We told VSCode where to find our binary. So now we can go ahead and reload the window or restart the extension host, either will work. And then we can go and make sure that this is actually doing what we want. So we can go into the output window, which is usually next to the terminal in VS Code, although I have kind of reorganized things a bit, but you can probably find it. And then we can look at the Haskell MuniHac window, and then we can see that this is indeed coming from our local path. And another thing we can see here is the list of plugins that we are loading. Okay. So we're gonna add our plugin. We're going to disable the existing import lens plugin, which is the one that we're going to implement. And we're going to add a new one called MuniHac. So let's do that. So obviously, let's go to the Cabal file. There's a lot of Cabal files. And here we have the list of plugins in the executable stanza. We're just going to add a new one. We can comment this one out here, but we're not going to bother. Now, let's go to the main module and import it. There are some scary errors. I hope that everything is working. Oh, probably because we edited the Cabal file. And It's just reloading. Okay, so now let's comment. So the list of plugins is here in the exe file. They're all kind of hard-coded here. If we want to comment one out or add a new one, this is how you do it. We don't have a MuniHac module yet, so I'm just writing this, and now we're going to create the module. So all the plugins live in this folder, plugins, oops, sorry. Plugins default source IDE plugin. I'm just going to create a new one. And there's something here. This is called, well, let me check. Plugin descriptor.
Just out of complete curiosity, why didn't you have completion for that?
For plugin descriptor?
Yeah.
Because things are not type checking at the moment. So let me reload. We've made changes to the Cabal file. We've added a new module.
Oh, okay, okay, sorry. Yeah.
There's a bunch of errors here.
Did work for me when I just tried the same thing, but
that's good. But that's good to hear. So we can do this Haskell restart Haskell LSP server, and this should have the same effect. What have I missed? What is nothing working for me right now? So let's see the project builds, first of all.
So what? Okay, sorry, now it's finished. But I mean, one reason why I was asking about configuring the plugins before is if they're all basically enabled by default, then it does mean one has to be rather careful about the performance overhead that every single plugin introduces, right? So it's not free to add more and more plugins to Haskell Language Server. If everybody of us is writing their plugins, then it'll just get unusable all the sooner. Or
that is true. So that's why it should be possible to toggle plugins on and off. Because when a plugin is off, it doesn't contribute any cost at all. We do have a benchmark suite in GHCIDE to cast performance regressions, but not in Haskell Language Server, at least not yet. But this is still not happy, and I don't know why. I'm just gonna go ahead and fill this in with the default plugin. I think we need to change the type to take a plugin label, default plugin descriptor and plugin ID. But there's still a bunch of errors here, which I cannot explain. Well, it should be building now. Let me check the builds. Yeah, so that built successfully.
Is this also an HIE.YAML problem, perhaps?
Oh, yes. So I bet that I forgot to link the default. It's IDE.YAML. Yeah. So we're internally discussing what to do in this scenario, because if you don't have an HIE.YAML, which is part of the Pi BIOS interface, nothing works really. There is this notion of an implicit IE YAML, but it's poorly supported, and it would be better to just fail with an error and say, look, you need to create a high YAML. You can use this tool to do it for you, but I cannot continue.
Yeah, actually, I wanted to share the same experience. I was trying to set up HLS with Emacs, and I believed I did everything right, just that I had glossed over the copying the HIML step, and I lost like 3 or 4 hours, like just figuring out what's happening, because we don't get the error saying that's because of that, right? I think the HLS tries to be intelligent, it tries to infer, but it fails to infer. We probably should just like fail.
Yeah, as I say, it's very poorly supported, and unless we improve the support, you get it to just fail early. And there's an internal debate on what to do here, because failing early with a weird error message like you don't have a high YAML, that is meaningless for most people. It's not the most friendly experience. But on the other hand, trying to continue and fail in some other even weirder way is not helpful either. So,
Right.
Would it be within the capabilities of the Haskell Language Server protocol to just make it interactive rather than having some sort of default? So if there is no HIE.YAML, then give you some sort of interactive choice, or is that something that just goes beyond the options that Haskell Language Server provides?
that's an interesting question. So you want to find a solution that works for any editor. So I mean, we could do whatever we wanted in the VSCode extension, but that would only work in the VSCode extension, and we want to give the same experience everywhere. So I think it will still be possible to do something within the confines of the LSP server to detect this and have a command. But who would be calling this command? Well, right. So I think it is still possible to do something. It's a good idea. I'll write that down for discussing with the team later. Okay. But let's continue with the workshop. So now we have a working environment, and what I wanted to do was to define this using a typed hole, because they started working quite nicely, and now you can do this. Oh, not that. This. And even if we don't have the right type, you can also do this. And then you can continue on. But the type that we want actually is plugin IDE to plugin descriptor. So let's do that. So now we have plugin descriptor, and now we've restarted the Haskell Language Server instance. Let's make sure that it's actually getting loaded. So let's go back to the output window, and let's check at the top of the file if it was loaded. Now, this is not going to be so easy because we have the full load. So let's apply a hammer, restart the extension host, and that will reset the log, and then we can make sure that that plugin is being loaded. And the reason it's being loaded is because we have rebuilt the binary, we have linked it into the main module, and therefore it should be getting loaded. Yeah, it's here. Okay, so now we have a plugin, but it doesn't do anything. let's add a code lens provider that doesn't do anything. So the field name was, actually, I don't remember the field name, but maybe we can find out. This is still working on setting up. So one disadvantage of restarting the extension host all the time is that now we have to wait for the project to be set up every time, and that can take a while. Let's take a look at the definition. So we want a code lens provider. Plugin code lens provider. And that's going to be of type plugin code lens provider, sorry. So what's in a code lens provider? So like other providers, a code lens provider takes a couple of things, including an LSP funcs config. So LSP funcs is a record of LSP utilities that is provided by the Haskell LSP package. So we can take a look. So we can check the client capabilities, we can check the config. We have this send function, which allows to send any arbitrary messages to the client. And we have a bunch of other utilities like, I don't know, publish slow diagnostics. We can publish diagnostics manually. This is not needed because GHCIDE takes care of that. We can generate new IDs, which are used for some of the messages that we might want to send. And then we can communicate progress for long-running actions. So this is actually quite useful in commands. There's a couple of examples that use, a couple of plugins that use with progress, so you can find examples of this in the code base. So, but most plugins don't really need to use any of these utilities because either HLS or GHCIDE already take care of most things for you. So we can ignore that for now. The second thing that the code lens provider function takes is an IDE state, which is check database plus a persistent store. So this is basically the GHCIDE internal state and allows the plugin to execute GHCIDE rules. Then comes the plugin ID, which I think is used for creating new commands, but I'm not sure, or maybe it's just an implementation detail because I think Haskell Language Server will use this to automatically route messages to the right plugin. And then a set of specific code lens params, which is another LSP thing. So let's take a look at that. Right, so code lens params contains the text document ID on which this code lens is being provided, is being asked to work, and a token that I think we can ignore. I don't recall having used this token at all. I think this is for reporting incremental progress. So let's go ahead and flesh out our code lens providers. So we have the LSP funcs that we're not going to need, and the GHC state that we're not going to need initially either, the plugin ID, and the params. And what does it do? So it returns a computation that produces either an error or a list of code lenses. So without going into the details of what code lens is, let's just implement a nil lens provider that returns the empty list. And we need to import let's just import development IDE, which contains all we need. And then later, when we have a working code lens provider, we can see what we are actually getting from these modules. So let's start a message. Let's print something to the console. I usually print the standard error, but it doesn't really matter. Now let's import what we need and build. Oh, in order to build nicely, I'm just going to copy my VSCode tasks to this folder. And then I can just do, or actually I can do this. Or just do task from build task. So that just calls Cabal build inside an Excel. And that's working there. And then once it's built, we can restart the extension host and make sure that Hello MuniHac is getting printed out. And then the next step will be to actually do something useful. And by something useful, we are going to implement the task, which is obtain the list of imports. Let me restart. And I guess we can just start by, in the spirit of doing things incrementally, we can start by just generating a code lens on top of every import that says Hello MuniHac. But actually, let's do that just now. So let's have a single code lens that says Hello MuniHac. So while things are loading, we can go and check the output window and verify that we got the Hello MuniHac. This is very chatty because I enable the full messages, the config, which is probably not helping. So let's see if we can find Hello MuniHac. No. Now that's odd, but let's go ahead and produce the Hello code lens, and then that would be another way to verify that our client is working. So the Hello code lens, what is in a code lens, and why do we need a type here? So if we go back to the IDE types module, we can try and see, well, because things are loading, we don't have help. But basically, this code lens is a type that comes again from Haskell LSP types. And it contains a range that the code lens is attached to, possibly a command that will be executed when the user clicks on the code lens, and then some extra data, which is just a raw JSON value, which can be used by the LSP server to keep some state, or maybe to communicate additional details. Actually, when in doubt, what you can do is you can go to the LSP specification. You can look at a specific thing that you are interested in. So in this case, we're going to look at the language features code lens. And then we can get a little bit more detail on what's going on here. So this is the interface definition. I think this is TypeScript for code lens message. And the third field that we were looking at is just a data entry field that is preserved on a code lens item between a code lens and a code lens resolve request. And then the resolve request is only used for code lenses which have no command. So I guess this is a facility to keep things responsive. So saying I have a code lens I want to show, but I don't have a command for it yet, so maybe you can ask me later and I'll give you the command. So we can ignore this. And we can simply go ahead and create the code lens that we need. I'm not sure why this is not suggesting me an import. Maybe all these reloads are confusing things, but the code lens type we saw in Hugel is defined in language Haskell LSP types. So let's import a module.
I'm surprised you seem to be getting these code lenses for your import statements right now, even though you disabled
Yeah, that's a good point. I disabled them. So what's going on? Maybe when I copied the tasks, I screwed something up. So this is still using, oh, look. It's using the wrong version of Haskell Language Server, because the one that we want to use is the one that comes from MuniHac. And while I'm here, let me disable this communication to hopefully get a less chatty output. And let's restart again. Now let's check the output. And yes, this is coming from MuniHac, Scratch MuniHac, so that's the right place. And it does contain the MuniHac plugin, and there is no import lens plugin. And hopefully, if we wait for a while, we will be able to see hello MuniHac message at some point. But I'm not going to wait for that. And instead, I'm going to define our hello code lens. So that was just the code lens constructor with a range command data. So range, we have to define a new range. So let's just define the range that covers the first line. And then for command, we're not going to have any command. And the other field, which is, I think it's data. Yeah, again, nothing. And let me replace my typo. And now this is pretty annoying. If anyone knows how to deal with these duplicated record names, please tell me, because I always find this extremely confusing. I don't know if there is a combination of pragmas that makes it go away. Possibly this one. Okay, seems good. Okay, so we have a code lens now. It's just that without the command, there is no text. So the code lens cannot display anything. So we actually need an empty command with some kind of text in it. So empty command will be of type command. So let's define it here. And well, I'm just gonna guess, yeah. So command has type text, maybe a list value, and that's it. So I suppose this is gonna be the title. So let's do hello MuniHac. And this is going to be the command ID, so non-existent command ID. And then there's a list of arguments. This is going to be, oh, actually, it's a maybe list, so we can just do nothing. And we are going to need overloaded strings, because those are text fields. Okay, so that's good. Let's build again. And in the meantime, let's start thinking about what we need to do for real. So we need to obtain the list of imports. Then we need to find out the explicit import lists for those. And this is done by GHCIDE, so we will just ask GHCIDE for that. And then for every import statement, now import list, regenerate equivalence. So let's start by getting the imports. So we are going to define a new get imports action helper, and this is going to need to take some kind of file identifier. And in Haskell Language Server and GHCIDE, we use this normalized file path type for that. And it's going to produce a list of imports, which in GHC, they are of type L import declared for located import declaration, and then some ID, which in this case is going to be GHCRN. So you can just import development in IDE GHC compact, and that's going to bring everything we need into scope, or mostly everything. And then let's go ahead and do something here. And we need to figure out where to get the NFP from. But let me go ahead. So the build completed, and I hope it completed successfully, yes. So let me go ahead and start the Haskell LSP server again. And you can see why this gets a bit annoying. So actually, let me see if I can open a new VSCode instance, just pointing to some other project. And then we can do the reloads in that one. Then I have an empty project here. And then we need to, again, make sure that this is using our binary, which it is. And then I will be restarting this instance instead of the one that we are actually using to do the work. So let's take a look at the output. Oh, we didn't open any Haskell files, so there's no output. Right, so this is working now. And yes, it has loaded the MuniHac plugin, and it is hopefully using, no, it's not using the right binary, I don't think. Okay, so that should be using the overriding the user settings. So let's start it. Okay, well, so now it is showing the hello MuniHac code length. It's also showing an error here. Oh, this is the wrong GHC version. Okay. So I fixed that by editing my shell.mix file. You would not have that problem if you're using the same GHC version everywhere. But we have the Hello MuniHac codes here anyway, so this project is already set up correctly. I'm just going to restart it with the right GHC version, and then we can continue. Okay, so we're trying to obtain the list of imports, and for that we need to have a normalized file path, and then we need to do something with it. So the normalized file path will come from the code length params, because if you remember when we looked at the definition before, the code length params to include a text identifier, text document identifier, and that contains a URI that we can use to obtain a file path. So let's do that. All the field names in Haskell LSP start with an underscore. It's a bit annoying. We need to enable name field puns. Is that the right field name?
Sorry, we have another question, and that is, what exactly is the path I need to enter for the LSP executable in VS Code?
You will want to enter the path of the binary that you are building. So in this case, it gets printed out by Cabal after Cabal build is completed successfully. Does that answer the question?
I think so. He hasn't answered yet, but let's continue.
Okay, so we're going to extract the normalized file path from the text document identifier, which is contains a URI. So we're actually going to use a pattern gap because it's not a total operation. So we want to be able to detect that and fail nicely. So let's do an actual pattern match for the text document identifier, just to avoid issues with duplicate record fields. And then let's pattern match on the actual result of transforming this URI to a normalized file path. So we know GHC knows that this is of type normalized file path because we're using it down here. And we need a function to perform the conversion. So we want something of this type. There isn't something of this type, unfortunately. So we are not going to get a useful suggestion. But yeah, that's a bit of a shame. But there are some completions that we can use. So there is a URI to file path comma, and there's a URI to normalize file path. So we need to use this one, the first one, because we have a URI, we don't have a normalized URI. So let's use this, and this is going to give us a maybe file path, and then hopefully we can figure out. Oops, no, that's not right thing. Okay. So hopefully now we can get a useful suggestion, because there is another function that takes us from file path to normalized file path. And now we have what we needed. And we can start trying to get the list of imports. So how do we get the list of imports for a module? Well, we ask GHCIDE for it. And there are two ways to do it. We can get a list of imports from the parsed AST, which is probably what you do in most cases. We can also get the list of imports from the type checked AST. And we're going to do the second one because later, when we want to get the minimal import lists, we are going to need a set of imports that has type checking information. So that's why we're not going to use the parse AST this time. So let's do that. And we're going to move this function to the action monad, which is the shake monad for, which is directly used by GHCIDE for requesting build results. So we get the type checked results. We can use the right type because it's already in the scope, I think. Well, actually, I don't know what the right type is, so we will have to look that up. I know what we want to use, which is this rule called type check, and we use it this way. And then that produces type check AST. And then we do something with it. So what does this rule produce? Well, we have to go and find out. So how does one go and find that out? There is some documentation, but that's probably not going to tell us. Actually, it is, because we can see the instance details, and we can see the rule result instance, which contains or which specifies the type of the result. And that's going to be, sorry, wrong instance. That's going to be TC module result. So let's pattern match on that. And actually, the completion is pretty nice because it tells us the full type. So we can see the fields or the type of the fields already. But what I want to use really is the names of the fields. Because that is, I prefer to use field names instead of just pattern matching for constructors. And actually, the diagnostic tells us what they are. So we have TMR module, or we could just, we have the hallux on the right-hand side. We can just go and check the hallux. So let me collapse that and go and check the hallux, which we have around here, yeah. So we have a TMR module, which is a type check module, and then some other fields which we do not care about right now. So let's go ahead and pattern match on the TMR module. Then what do we have inside this? Okay, so this takes us to a GHC type. So the type check module is a GHC type. That contains a bunch of things. Now, inside here somewhere are the import lists that we want to obtain. If you don't know GHC API, like most of us, just go and look around. I happen to know that they come from they are available in the parse module, but they're also available in the rename source with better or more precise identifiers, which is exactly the variant that we're going to need later. So we're going to pull them out from here. Now, the rename source is an AD, but we happen to know that it's always going to be populated. Just because of the way that the GHCIDE invokes the type checker. So let's extract them from here. And what is rename? What is in a rename source? So let's find out now. Right. So a rename source is a tuple of 4 things, and the second one is the imports. Excellent. So we have our imports. Now let's see what's this error here. Pretty much. Right. So the problem is that use returns an AD because it says request a rule result if available. So we have to handle that case. So let's go ahead and do that. And well, this gives us a nice way to handle the pattern match or the maybe in the rename source, so we can have a guard here as well. And if everything goes fine, we return the imports. Otherwise, we return the empty list. Okay, so that's get imports action. Now we need to change the way that we're calling it here, because get imports action returns computation in the action monad, but we are actually in the IO monad here, so we have to run it somehow. Now, so how do you do that? So if you've read the tutorial, you will know that there is, you will know the solution. There's an action runner provided by GHCIDE. Unfortunately, we're not going to get a suggestion for it because it takes 2 arguments, and our settings, the default settings for typed calls, do not see that bit. And the arguments are a description of the action that we're running and the GHCIDE state that we receive as part of the columns provided arguments. So now we can find it. It's called run action. It would be nice if the default settings for typed calls had a depth of 3 or more, but unfortunately it's a bit too slow. So it can take like 8 seconds and then you don't get any diagnostics, and it's not ideal. Okay, so we have the imports now. Now let's just go ahead and generate a code length for every import where the title of the code length is just the import itself, so that we can see some progress. So let's do that. First of all, we are going to extract a little helper to define code lengths. We're just going to parameterize it by the command and the position. And then we can use it up there. I think if we do this, fold make code length, this might work. Oh, look at that, beautiful. So that is using the retree plugin, which can which implements folding and unfolding of functions and type synonyms and GHC rules, group backmask, and I think it can also do pattern synonyms. I implemented it, but it doesn't do pattern synonyms in Haskell Language Server yet. Okay, so now with that helper, we can get rid of the hello code length, or let's leave it for now. But we can generate import code lengths first as well. So we're gonna make code length where the range is gonna come from the import itself, and the command is going to come from the import itself as well. So in order to do that, so let's iterate through the imports first, extracting the location and the actual import. And so the range is going to come from the location somehow. And there are no code actions, so we're not getting any useful suggestions because everything is broken. Let's define a helper function, make range. And let's define a helper function make title that takes the import for now. And let's define a helper function make command. So we're going to extract from the empty command here. So here we're going to want to have at least a title so that we can customize the title of the command. For now, we don't have any command handlers, so we don't have any command ID. And what's the error? Right, so type seems error. And let's fix that by importing data text. Okay, so now we just need to fill in make range and make title. Let's define those helper functions. Now for make title, really, I was hoping for a useful suggestion because we want just to pretty print the import declaration, and there are helper functions that can do that, but they produce strings. They do not produce text. So let's be nice. Well, let's be nice. Let's just call text.pack here so that the types match, the types align, and we get a useful suggestion. Yeah, if replace make title with pretty plain, that's exactly what we need. Okay, and that is coming from development IDE GHCIDE util, and that's imported by development IDE. So then we are using. Okay, and then we still have to implement make range. If only there was something that we could use. Now, if we try, we're not going to find any suggestions, I don't think, other than the idempotent suggestion. That is because GHC has this source fund type, which can either be a real source fund or an unhelpful span. And if it's an unhelpful span, you don't actually have a span at all. But we want to work with the real ones because those are the ones that we're actually using, and those are the only ones that we can use to reduce range. And for those, we do have helpful suggestion, which is real source funds range. And then now we only have to pattern match for the location value here to ensure that it is a real source fund. And then everything's good. And given that make range is just real source funds to range, let's just unfold it. Okay, how it doesn't work for some reason. Oh, let me save the file and try again. Ah, makes sense. So we need to fix the plugin to save the file, or use the buffer from LSP. Okay. And this comment now went out of place. That's unfortunate. Okay. And now we can also get rid of the empty command, or at least replace it with make command. Okay, that's nice. And well, let's go ahead and use the import lenses here, return them as part of our provider, and we just get rid of this now. Okay, so what have we done? We have written code to obtain the list of imports from the typesect artifacts of the module that is being analyzed. We have used those imports to create a list of lenses where the text of the lens is just the import itself. And we just return those import lenses now. So we can also get rid of this put string. And I'm already building the project. So let's see if that works. Let's reload in our second Visual Studio Code instance, just to make sure, yeah, that built successfully. We can go ahead and start the Haskell LSP server. And did we get something wrong? Where are our code lenses? Okay, so this is not giving me any hover, so it might be that it's not loading successfully. Let me restart the extension host, maybe that will help.
Is your lens provider exhaustive?
Ah, good point, Andres, you're right. So we need to add an equation for the case where we cannot obtain a normalized file path. And in that case, we just, I mean, we could return an error, but what would be the error? What would be the diagnostic? We just return the empty list. So that could explain why things were not working before, if things were running out, but I'm not sure. Let me build again. Unfortunately, GHCIDE doesn't display missing cases in case expressions or in equations, because it doesn't run the I think it's done in the simplifier or in the desugarer, and GHCIDE doesn't run that part of the GHC compile pipeline because GHCIDE only runs up to type checking and it doesn't do any more work than necessary. I think there's an open issue in the issue tracker to do that, but that could come at a cost in terms of performance. So I don't know if we want to do it. Depends on how expensive it is. Okay, so I rebuilt. Let's go ahead and let's start the extension host again, because I would expect to see code lenses now.
It does work for me.
Oh, fantastic. So that's, yeah, I don't think we've made any obvious mistake, but obviously I could be wrong. Let's see if I get hovers. No, I don't seem to be getting anything at all. Oh, because the project is not building, because I changed the GHC version for this. Now we get build errors. Because, yeah, the plugin, the Cabal descriptor has base bound. Okay, so that should work now. Yes. Is it a good moment to take questions and do a break? Because we just, I think we're just halfway, right?
Yes, we're close to halfway. So if you'd like to take a break, I think it's a good point. Also,
Yes.
for any leftover questions, if there's anyone still wondering about things, I have one person in Slack who also had issues with seeing types documentation when hovering over identifiers.
So is that like a setup problem or?
Oh, that was me. And I'm wondering if it's an issue. So I have no problem when I look at my own project that I compiled with 865. Oh wait, sorry, which version? I was using a different stack resolver. I don't know. When I compiled HLS, and then I brought it up in VS Code, and it downloaded the Haskell Language Server version, the appropriate version. And if I looked in the output window, when I hovered over things, the output window said it was invoking the hover operation, but nothing actually appeared in VS Code.
So one thing that you can check is the problems tab, which you can bring up with Control-Shift-M. But it could be that your project, like your Cabal project, doesn't build or just doesn't, because I mean GHCIDE or iBios technically doesn't need to build your project, but it needs Cabal to be able to load it. So it might be something like I have, or it might be a dependent module that doesn't build and or has a type error or something like that. So
I had already built it.
So do you have anything in your problems panel?
Well, I closed it now because I'm rebuilding. I thought maybe if I rebuilt with a different version of GHC, it'll work. So. But
check the usual things. Check that you have a high YAML file. Check that you're using the right version of Haskell Language Server, version that matches GHCIDE. Check that your project builds, and I mean, if all those three things are positive, then I would expect it to work. If it doesn't, look at this output window and see if there's anything useful and file an issue or ask in the ISC channel.
Okay.
Okay, so let's take a 5 minutes break. So we will be back at, well, 5 minutes from now, depends on which time zone you are. Cool. So before the break, we were generating a code length for every import, and we can see that that's working. We can add more imports and get the code lengths. But there is one issue, and that is if I edit my file and while I'm editing, I break the parser or I introduce a type error, the lengths disappear. Well, actually, they don't disappear if I introduce a type error, which is interesting. But nevertheless, that's interesting because I'm using type checking artifacts, so I don't know how that works. But in any case, there's a simple fix for this, which is to allow GHCIDE to use stale data. So what this means is if it is possible to execute the rule that you ask, so in this case, the type check rule, that's fine, and GHCIDE will give you the result back, or shape rather. But if the rule fails because fails with an error, or yeah, well, basically if it fails with an error, GHCIDE will use the last successful execution of this rule to fulfill the request. And that means that, well, if we are editing and break the parse tree, we will be showing the import lengths for the previous version, the last successful parse tree for the file, which is, it can be incorrect in some corner cases, like if the user is editing the imports and adding or deleting imports and while the parse tree is broken. But most of the time, it will be okay. And even if it's incorrect in some cases, I think the user will prefer to cope with that small temporary inconsistency rather than have to cope with the up and down movement of the text in the editor. So let's go ahead and call use with step. And it has some documentation actually, which we can see in the completion results. Request a rule result, if not available, return the last completed result, which might be a stale. And it returns an action maybe of a tuple containing the value and the position mapping. So we can actually use this position mapping to correct the position of our lenses. So even if the type-check TST is stale, we could use this position mapping, assuming the user has not added any new imports to fix the positions. We're not going to try to do that, but it's obviously it's possible to do it. So we're just going to ignore the position mapping for now. And that's the only thing that we need to change in order to use stale data. So what happens the first time that the plugin asks for the type-checked results for this module? Well, there is no stale data available. So if the plugin, sorry, the module doesn't parse or doesn't type-check, well, there will be no code lenses because GHCIDE wasn't able to provide any type-checked artifacts. But that's fine. So I'm going to build now, and we can switch and check that it works later. In the meantime, let's start thinking about what's the next step. So we don't want to show a code lens in every import. We only want to show a code lens in every import that doesn't have an import list, okay? And obviously, we want to show the explicit import list as well, but let's start with this simpler step, which is just filtering out those imports which are not interesting or not relevant. And by relevant, we mean, well, let's just call it is relevant because there might be more than one condition. There is more than one condition that makes an import relevant for this lens. Okay, so we can go ahead and define is relevant. It's a bit annoying that this screws up the position of that color. So what are the cases that we need to consider? So first of all, it's relevant if it has no import list. And is not a qualified import, because we don't want to display import lists for qualified imports. Because, well, the purpose of this plugin is to help you locate where identifier is coming from. And if it's a qualified identifier, well, you already know where it's coming from. So it's not strictly as useful. And finally, it's not the prelude. Because the prelude is imported explicitly in every module. And actually, if we go back to the Visual Studio Code where we have our extension running, we can see that there's a code lens in the first line for the prelude, import implicit prelude. And then we don't want to display that. So we're going to filter out import declarations for prelude. OK, so let's go ahead and write this. Let's take a look at the documentation for this type, import decal. So it's actually quite easy to write, because an import decal is just what you would expect. That's not always the case with the GHC API, but in this case it is. So we have a field for qualified, which is of type import decal qualified style, which is roughly a Boolean. We have a field for implicit, which corresponds to the implicit import of the prelude, so we can use that to filter out the prelude. And then the list, the explicit import list, is communicated in this last field, idecal hiding, which is okay. It's not the name that you would expect, but that's where it's coming from. So so let's go through those cases. So we want it to have no import list. Now, in what cases do you have no import list? If this field is nothing, or if this field is just of true. So let's just catch the case where this field is just of something. And then filter out the case where it is hiding, because, well, actually what we want is to catch the case where it is hiding, because in this case there is no explicit import list. So let's just state the list of conditions, because it's just a Boolean. So if it's hiding, and if it's not implicit, and if it's not qualified, and for that we need to compare the IDE or qualified field with the right constructor, which will be not qualified. Okay, so in these cases, it is a relevant import. It's also relevant if identical hiding is nothing. And in all other cases, we don't care about it. Okay, does that make sense? So I think that covers all the cases. And so this covers the prelude. This ensures that, no, so hold on. So this should be, yeah. So actually, I'm confused. This should be hiding or not hiding? Hiding. And the case where it's not qualified. Okay. So we can go ahead and test it, because we're already using it here to filter out the list of lenses. So now this is going to be the list of relevant import lenses. So let's build and test. And just going to do warnings. And that should be built. Yeah. So let's go and reload and check. Now let's introduce some qualified module and some hiding module. And then finally, a module with an import list. And something is not working, because so the qualified case doesn't seem to be working. So we got the explicit import list case fine. It's not showing a lens. We got the hiding case fine. So it is showing a lens in this case, as we want. But we still have the prelude there, and we still have lens for a qualified module. So what did we miss?
I think it's because you're only checking the implicit in the case that the hiding clause is there.
That's a good point. So it might be easier to change this to a negative predicate instead, so that we don't have to duplicate the condition. Okay, so a plugin is not relevant if it has an import list. So sorry, an import is not relevant if it has an import list, or if it's implicit, or if it's qualified. And in all of the cases, it is relevant. Cool, let's test again. So it looks like it's built already. Okay, it's still not right. And it's failing the qualified case and the implicit case.
Isn't that for the same reason though as before? I mean, you're only checking the qualified and implicit case if the hiding clause exists.
Yeah, I suppose so. Let's go back to the previous version. I mean, I just want to avoid having to duplicate the condition. So, but I don't see, well, yeah, I think they should do it, right?
Yes, as far as I can currently see, yes.
So if
I mean, you previously had yet another case, which I'm not sure whether it was needed. I mean, you were matching on.
So if the import list is not there, then it is relevant. If the import list is there, then it is relevant as long as it is not, as long as it is hiding import list. Yeah, so I think this should be fine. And if this doesn't work, I'll just copy the solution because can't be.
Is import decal the only constructor of import decal? Because I mean, before you had 3 cases, and I'm not sure whether. Because
I was pattern matching on the maybe inside IDE hiding, but yeah, it's the only constructor. So
then that was redundant already, right? Because you were pattern matching on the 2 cases of the maybe and the just and the nothing. And...
Yes, that's right. Yeah, that was the
right.
Okay, see what it is right now.
Well, actually, it is claiming for me that it's non-exhaustive with X import decal.
Okay, so that could be one of the special constructors for trees that grow. Right, so I think it's fine to just ignore that case, say that it's not relevant. But other than that, this does the filtering that we wanted, because it doesn't show me a code lens in an explicitly imported list, and it doesn't show me a code lens in a qualified import, and it doesn't show me a code lens for the field. So we're good. That was a bit painful, but it's done now. Okay, so the next step is to actually find out the explicit import lists and show those instead of showing just the original import. So usually you would have to do some work to do something like this, because I mean it's a simple problem, but still you have to go through the program, find out all the identifiers or all the unique identifiers that it contains, and then find out where they come from, and then that would be pretty massive, right? There's code GHCIDE that already does that. you just need to look for it and find it. So I think it's called get minimal imports. So this time the name is helpful. And it doesn't have any documentation, but it does what it says. So my Zoom is saying that the preferred microphone is disconnected. Can you still hear me? Okay. Right, so you just need to figure out how to use it. It takes a list of import vehicle usage, which is conveniently produced by this find the import usage function above. So really, it's just a matter of writing some code to put this together. I am going to skip that and just get a solution from the existing plugin. Because otherwise, we're going to waste too much time. Because it's just an exercise in wrangling the GHCIDE API. So there's this extract minimal imports function. We can go through it. We need to add a few pragmas, few imports. Okay, and that works. And so what it does is even an HSC environment, which is basically what GHC, the environment with all the state for GHC, and given the type checking module result that we already have, it will return the list of imports and the list of minimal import lists. And it does so by using the getting minimal imports function that we saw before, and that's about it. It's using the parse module. It's using the rename source to get the imports as well as we are doing already, and it's using the parse module just to get the location of the entire parse source, which I don't remember what it's being used for actually.
Sorry to interrupt. We have two more questions, and one is if a VSCode Live Share is available.
I didn't start it because I realized I was going to have to be restarting the extension host, and that was going to disconnect the live share. So didn't think it was going to work well. And
then we have in Slack an error message from someone, invalid option ---- LSP.
Oh, that's
yeah, that's because.
Oh, yeah, someone answered already.
I mean, there are multiple binaries being built by Haskell Language Server, and this is the wrong one. But actually, I had a question related to this as well. There seems to be a Haskell Language Server and a Haskell Language Server wrapper.
Yes.
Which of the two is the one should actually be using? Because they both seem to work.
That's a very good question, Anders. I have no idea. I cannot remember what the wrapper is used for.
Okay.
It might be used to detect the version of your tools when Haskell Language Server is installed the first time. I don't remember. I think that's actually what it's used for. But I'm only guessing. All right, so let's use extract minimal imports to produce the lenses that we need. But I think that there's a better way to define this function. So I'm just gonna tweak it a little bit. So, okay, it takes the same inputs, but instead of returning a tuple of two lists, it returns a list of tuples, and that kind of simplifies the work that we have to do later. So I hope that makes sense. So it returns every import declaration tuple with its import list if it needs one. So we just want to build a kind of minimal imports map. And then we use it to build a solution. So what can we index the minimal imports on? So a simple answer is the line, because the first line of the span, because obviously every import is in a different line. So start line or start position, doesn't matter. And again, I think it's easy if we actually parse pattern match, because we want to get the real source span. And there's always going to be a real source spans there anyway, but to keep things simple. So how do we get the start position? I don't remember. Hopefully we can get a type called suggestion. What's the problem with this one? Oh, import is a reserved word, so we cannot do that. Oh, we cannot define a function calling get minimal imports because that's the same name as GHCIDE. So let's just call it find minimal imports. And obviously this only works if we have minimal imports. So and the only reason we wouldn't get minimal imports is if the module doesn't parse and we cannot obtain a result, I think. But actually no, because this is doing incomplete pattern matches. So, well, no, yeah, exactly. That's the case, yeah. So how do we get the start position? Well, we have to say exactly what we want. Otherwise, that's not going to work. Maybe let's just look at the documentation. It's not immediately useful. It looks like there might be something else in this file. Something called source file start. Actually, let's see if completion finds it. Yeah, source file start line. So I don't know why I didn't get suggestion for that. No, maybe 10 is not enough. Okay, and here what we want to look at is the stat line as well. Okay, so now that returns the minimal imports and the imports in the same list, and we can use that in our lens provider. So instead of calling get imports action, we call get minimal imports or find minimal imports. Actually, let's call it find minimal imports action, and then we can define a helper that requests all the things that are needed and runs in the action monad. So we want the type check result, and we want to use stale data for the reasons mentioned before. We also need an HSCM. We get that from another rule, which I happen to know the name of. Do we want to use the stale information from this one? Yes, probably yes. I mean, for the same reason. And then call minimal imports. And do it in the I monad. I see a question. It seems it is always useful to use stale functions. Is it that true? Well, yes and no. I think it's always useful to remember that you have that option and to have a thought about it. Because there are some cases where you do not want to use stale data, like you don't want to use stale data to show type signatures, for instance, or to show diagnostics or quick fixes. I would say that in most cases it does make sense to use stale data. Always keeping in mind the trade-off and the fact that it can confuse users. Okay. So this is just an fmap. Oh, hold on. These are in the wrong order. So this is fmap first. And this is fmap something. Yeah, fmap first. Okay. So now we can really call find minimal imports action instead of find action. and it returns another thing. So we need to handle that here. Okay, so what can we do with this maybe minimal import? Well, we can use it to create our code list. So assuming that it is a just, that's what we want to pre-print. And we can build and test. So
sorry, we have another question, and it's it seems it is always useful to use stale functions. Is that true?
Yeah, so I noticed that question, and I already answered it. Hopefully that was the
oh, my bad.
the expected answer.
Yeah, you answered it. Thank you.
Okay, no worries. So let's check that it works. So I would expect to see an import data list intercalator. Excellent. Okay, success. So I think at this point, we are almost done with the workshop, with the tutorial. So the next step would be to add a command so that when I click on the import code lens, it rewrites the import statement. But I want I think I want to skip that so that we can move on to the extension. Because I don't know how much time we got left.
We have another 50 minutes.
Yeah, so I think we should probably skip the command and move on to the code action. Well, actually, we're going to need the command. Well, let's do the code action, and if we need to the command, we will define the command as we go. I think this is the most interesting bit of this workshop, anyway. So let's do it. So the code action provider is going to provide a single code action to fix all the imports. Well, to rewrite them to have the explicit import lists. So let's define our code action provider, and it's only going to show when there are any relevant imports. So let's go ahead and take a look at the code action provider type, which is defined in IDE types. I would expect go to definition to work there, but the multi-component support is not always able to handle that, and we do not support jumps to go into definition to files that are in other packages, so that's why we don't get it. Okay, but looking at the actual Haskell code is easier than looking at this Haddock. So it takes code action provider takes an LSP funcs, just the same, and an IDE state, just the same as the code lens provider. And then it takes plugin IDE as well, similar, and text document identifier, which is also the same as the code lens. But then these three things are new. So first one is the range that the code action applies to. We only want to return the code action when we are in the range of the import list. Sorry, the range of the import declarations. And then code action context, I think that we can ignore that. Oh, Haddock is not working either. So I think code action context contains mainly a list of diagnostics, which we don't care about because we're not writing a code action to fix any diagnostic. And then finally, it just returns a list of CA results, which, again, I don't know why Haddock is not following links. Let's go to Google. Okay, so see a result is either a command or a code action. What's the difference? The difference is that if we look at the specification, that will tell us, basically the difference is that the code action embeds an edit and obviates the need to go back to the server for the edit, for the diff. Whereas the command case does not include any diff and is kind of saying, okay, I know that there is a fix for this, but I don't have the diff in my hands yet, and it's going to take a while to compute it. So I think, well, we could find that in the specification somewhere, but it's not immediately obvious. So, right. So if the client supports providing edits within a code action, then this mode should be used. So that's what I'm talking about. And that's the mode that we're going to use. We're going to include the diff in the code action because it's not too expensive to compute the minimal import lists. If it was, then we would return a command instead. Okay. So let's define our code action provider. Takes LSP functions, takes some state, it takes some plugin ID, it takes document ID, it takes some context. So I forget the range. And the context. And then returns a list of code actions. Okay. So we're going to need to extract the document ID just in the same way as we did before, or the normalized file path. That's coming from the doc ID. And then what do we need to do? Let's write that down. If the range is inside an import declaration, and there is at least one relevant import, return one code action. Okay, so let's go ahead and get the minimal imports because we're gonna need them. Using same approach as before. Find minimal import actions in FP. So I'm not sure. Oh, did the wrong thing. Okay, and now we can look at what is the.
Can you say again what this string argument to run action actually is?
That's just a label. It gets printed out in the log, and I think it also gets printed out in progress. Well, actually, not in progress meters, but yeah, it's just a label.
Okay. But does it have to be unique or something? I mean, is it my responsibility to make sure that no other action anywhere uses the same label?
No, that's not necessary. It will be useful if you're looking at a log of a crash or a log of a failed test. And if you have duplicates, it might be difficult to find out which one you're actually looking at. So it makes sense to make them unique, but it's not a requirement.
Okay, thank you.
So so now that we have the minimal imports, which well actually contains the list of full imports, let's go ahead and find out the first import line and the last import line. Now we need to consider the case that there might not be any imports at all. So I'm going to use head maybe. And you could think that head maybe is in the prelude, but I don't think it is. So I suppose I'll just define it. And now we want to get the line, start line. And I think we already know how to do that, but let's just write it, and maybe we can use retree later to unfold it. Okay. And we're doing this because we need to find out if our code action falls between the first import line and the last import line. And we need to get the first element of the tuple, because the tuple is the tuple of the import and the minimal import list for it. So we can do the same thing for last. Again, we need to use last maybe. And then we can define our condition is within, or is inside import. So that would be if the first line of the range is larger or equal to the first import line, and smaller or equal to the last import line. Oh. And actually, we need to do a little bit of maybe threading somewhere. And what do we do if there are no imports? If there are no imports, there are no there is no collection. So that's the much. And this is very easy to define. Okay. So at this point, I would suggest showing a code action that does nothing so that we can see some progress. So let's define code action. And one thing I really want to get someone is to write a plugin that provides completions for constructors, where it it provides text that contains the constructor name, and then type holes for all the arguments. And if there are field names, then also give me the option to have the field names in there. Because, I mean, now I need to count how many constructors these things has and what they are. So we have some text at the beginning, which is probably the title. And then the code action kind, which tells the LSP client how to display it. Is this a quick fix or is this a refactor? And then the next argument, the third argument, is a list of diagnostics. I think that's the diagnostics that this code action is going to fix, so that the LSP client can potentially display the code action next to the diagnostic that it fixes. And then the workspace edit is the diff that we want the editor to apply. And finally, the command is, if we don't have a diff, we can give a command. And that means that we can postpone the computation of the diff. Okay, so let's see. A title and 4 maybes. Okay, that wasn't so bad. Oh, and we should add this condition that it is inside imports. And we can also say, are there any relevant imports? Yeah, so I thought that would be enough. Oh. Okay. So we can actually encode the two conditions already. Is inside imports and has relevant imports. Okay. Now, when this compiles, obviously there's a problem here, and I hope everyone has noticed. We are calling find minimal imports, and that is duplicated work that we are already doing in the code lens provider. So this is where the ability to define your own rules enters the picture. So we're going to define a new rule to compute the minimal imports and to store them in the build graph. But before doing that, let's just go and check that we have a code action. So that's built already. We can restart. Just wait a few seconds. We can ignore this from the previous experiment. Aha! Look, that is our code action there. And it doesn't show up when I'm not in the imports. And if there are no interesting or relevant imports, it doesn't show up. Okay, so that's pretty good. So we could go ahead and implement the code action fully by computing the diff that is needed and then just returning it as a workspace edit in one of these fields, and actually this one. But let's go ahead and define a rule to share the computation of the minimal imports between this provider and the code lens provider. So to define a lens, I recommend just going to the rule types module in GHCIDE, which GHCIDE is a submodule inside Haskell Language Server repo, so I can just find it conveniently here and copy one of the existing ones, because that's always the best way to proceed, like copy and paste. Because there are a number of type class instances that the rule type needs to implement. So we can just take care of that. And then don't let me do a global search and replace. Let's just do a local one. Okay. So let's fix all the missing imports. Don't know what happened there. I think if we import development shape classes, that imports everything that we need. This one for some reason. Oh, right. So here we need to specify what is the result type. And this result type needs to implement a number of instances as well. So I think it's probably the case that we're going to need to define a new type wrapper for it. But let's start just with this type and see where that goes. So far, it seems happy, but that's because we haven't actually tried to define the rule. Oh, look at this. So this is actually nice. We can tell Retri to fold this type synonym in this file, and that's going to go and replace all the previous currencies of that big chunky type with the type synonym. So we will see that now that type synonym appears in more type signatures. I don't know why it doesn't show up in this one. I don't know why I didn't replace this one. Maybe it's not exactly the same thing. Oh yeah, because it's not the same thing. This is a list of tuples, sorry, a tuple of lists, and that's the one that we wanted to fix. Okay, never mind me. So yeah, so let's go ahead and define the rule, and you do that with define. Which comes from development.ide. So you can squint and look at the type signature there. It takes a function and it returns a computation in the rules monad. So let's call this the minimal imports rule. And let's try to see if we can, well, actually, instead of trying to guess, we can just go and look at an existing example. So we were looking at get known targets before. Let's see if we can find the rule for get known targets. Yes, here. And well, this one is using define early cut off no file. So that's not a good example, but right above it, we can see one that uses define. That's a type check rule, which we are already using. So we can just copy this pattern in our own rule, and then we can see what we need to provide. Okay, so let's take a look at this. Right, so the rule needs to return a tuple containing found diagnostics, and then maybe if there was a success, if the computation was successful, the minimal imports. So we already know we're not going to return any diagnostics, because if you read documentation, or if you read the recent paper on GHCIDE, it explains what the logic behind diagnostics is, but basically only rules. So diagnostics should never be propagated. Only the rule that creates diagnostics should be the one returning them. Otherwise, you end up with duplicates in the diagnostic store, and things don't work. Okay, and then there's some. Oh, right. So now we have the problem with the missing instances, and the problem is that it is GHC types that are missing these instances. So instead of going and creating a bunch of orphan instances, the simple thing to do is to introduce a new type wrapper and then put the instances in the new type wrapper. So we might have to change some code for that, but let's just go and do it. Okay. And now we can go ahead and define all the instances that are needed. So for this, it might be possible to just find an example as well. Let's see if there is one for known targets. So I'm trying to find the definition, or I could just open the shape module. Ah, no, it's just a type synonym. So, okay, well, let's go ahead and define them. It shouldn't be too bad. So you can just place holders, and then we can, take the time to do them properly.
Show minimal endpoints.
We're gonna need a couple more, so NF data for sure. And you can see why, because Shape wants to be able to ensure that the data that it stores in its database is fully forced, but we're not going to actually implement it.
I think you can just omit it. I think it's the default.
So the default will use the generic instance, or yeah.
Ah.
Oh, I guess we could just add generic. But that's going to complain that the
yeah, no, sorry. Yeah.
And that's it. So we are done. So now we can actually implement the code, which is very simple because we already have code to compute the minimal imports. So we just need to call it. And that's all it takes. And now we need to change our call sites to actually use this rule.
Sorry, does this change anything though? I mean, you've not specified any dependencies now. So when is it actually going to recompute minimal imports rule, and when is it going to share?
So that's a very good question. But the thing to notice is that find minimal import action is an action. It's in the action monad, and that is already implicitly declaring its dependencies because it's calling use or use with stale, and that's all that is needed. So we can see this is calling use type check and use GHC session depth. So those are the dependencies.
Okay, so the idea is that all the other IO actions you are performing possibly are deterministic relative to these declared dependencies.
Yes.
Yeah, okay.
I mean, what IO actions are you referring to specifically?
No. I mean, just because action is monad.io, right? I mean, we have been using lift.io in at least one place, and so we could.
Yeah.
I mean, I'm not saying about the ones that we necessarily are, but the ones that we could be performing.
Yes, that is right. So the only actions that we're performing in the IO monad are in the GHC session. So in the GHC, manipulating GHC values. And those are hopefully deterministic and hopefully thread safe. And it's been the case that the GHCIDE developers have found cases where this wasn't true. But this is a GHC bug. And those bugs are usually submitted upstream and fixed. And we're not doing any other IO actions, and you should not be doing any other IO actions inside the action monad. Okay, but the only thing that we need to change now is what we could do is inline find minimal import action inside minimal imports rule to prevent accidental mistakes where people call the function instead of using the rule. Because because the format is wrong. I wonder if we could play some trick with Retri to do it for us. Because so we can do something like this. So this is the implementation. And then find minimal imports. Just calling use. So do I have a name class there? Okay. And then what I want to do now is, sorry, actually I wanted to call this find minimal imports action, which is the same name as we had before. And then I wanted to unfold it. Just gonna unfold it again, just in case. Yeah, so now it shouldn't be used anymore. Anywhere else? Yeah, it's not used anywhere else. So it's been in line.
But it's changed the type, right? Now it's maybe everywhere.
Ah, okay, yeah, so that's why we were seeing some errors.
Why is it maybe again?
Yeah, I was thinking that. Why is it maybe? So the first thing is that we want to change this to use with stale. And then we can remove this use with stale because the stale values are already kind of gated by the get minimal imports node. Okay. And then we can, I guess we have to tweak the result if we want to be able to use this in the places where we were using find minimal imports before, right? Or find minimal imports action before. So what find minimal imports action before was doing probably was, yeah, it was returning an empty list, I guess. So that's what the implementation does, right? So that's the only thing that we can do here. We can say, okay, if nothing, then return maybe an empty list or the first element. Well, an empty list of type minimal imports. Because every time we call use with stale, there's a possibility that the rule might not be available, right? And now we can inline this bit. But hold on, what are these errors now? Okay, right. So now we no longer need to do the fmap first here. So this one we want to inline, and this one we want to inline as well. Okay, so that should be completely inline, no uses anywhere else, so I can delete it. And this one as well. Oops, that one didn't inline cleanly for some reason. Well, we can see all the intermediate values where something has gone really wrong. Yeah, it looks like there's a bug in the retrieve plugin. So what I'm going to do is I'm going to revert the buffer to the last version we saved. And yeah, I stop playing with retrieve. We can inline this one manually or just leave it as it is. But the point is that we have defined a new rule that caches the results of calling find minimal imports action input. And that means that now this result is shared between both our providers. And GHCIDE or Shake will take care of dirtying and recomputing it whenever any of the dependencies change. And if we wanted to be even more precise, we could define a rule with early cutoff. But for that, we need to do a little bit more work. We need to provide a fingerprint. And that means that whenever the minimal imports don't change, so even if the dependencies of the minimal imports have changed and we have recomputed the minimal imports, if the minimal imports themselves are still the same, then we don't need to, we can tell that to anything that depends on the minimal imports downstream, if there was anything, and they can use this information to avoid redoing work. Because they know that, well, the minimal imports are the same as they were. So if you want to know more about that, you can probably check the documentation of early cutoff, or if there isn't anything, probably one of the Shake papers. But this is this can be quite important for performance. So knowing when to define a rule as early cutoff. But that's not the case for this one for sure, because it doesn't have any dependencies downstream. Okay, so maybe let's try to wrap this up by defining the last bit that we need, which is the diff. So the workspace edit. So let's again use the completion provider to find out what we need to provide. So it takes two arguments, both of which are maybes. The first one is a workspace edit map, and the second one is a list of text document edits. And you may ask, what's the difference between the first and the second? And you can go out to the LSP specification and find out, but I can tell you that basically the difference is that the first one is, I think, richer, or actually maybe the second one is richer, more feature complete. And the first one is, on the other one is the kind of the backwards compatible option, because in earlier versions of the specification, only one of them was available, and then the other one was added afterwards, or something like that. So I think there's the type of clients that can handle both and clients that cannot. I don't think that there's much difference for us. I think one of them supports version edits, whereas the other one doesn't. So that might be useful, for instance, in the retrieve plugin, because the command is executed after the code action has been created. So you might want to make sure that we're applying the div to the same version of the document that you actually created the div for. But in our case, that is not a factor. So we can ignore that detail and just provide one of them. I'm more familiar with the first one, so let's go ahead with that. So this is workspace edit map. Oops. Let's see if we can get a suggestion for that. Nothing. So sad. So what is a workspace edit map? I don't think that it's a constructor. So let's go to Google and find out. I think it's just a map, really, of URIs to edits. It's a hash map of URIs to a list of edits. So we have our URI, because the edits are only for this document, and then a list of edits. Oh, someone really needs to sort this list of suggestions. This is really hard to find. Hash map strict. There you go. And then edits, which is a list of, what was it? Text edit. Okay, so what's in a text edit? Okay, so it's just a range and the new text. So it's a kind of simplified div. That should be quite easy. Because all we need to do is iterate through the minimal imports and the imports. We don't actually need the import. We only need the minimal import. And again, import is a keyword. Oh, I already did that. Okay. So the range we're gonna get from the source span for the import, which is in L, and the new text from the minimal import. Which is a maybe, so we only care for the case where it's a just. And that should be right. So we need to pack it. And now that should be good. And then for the range, we know that we want to grab the real source span case. And then we should be good. Okay. And we compute this list of edits unconditionally. So we compute the code action unconditionally, but we have this predicate here. So it will only be returned when we are inside the imports and when there are relevant imports. So that's fine. So I think we can go ahead and check if our code action works. It looks like there is an error. Oh, that looks like a multi-component bug. But let's look at the console output to make sure that it built. Yes, it seems to have built. Oh, we need to add additional equation for code action provider. And that should be it. And we can go ahead and test it. To make this a little bit more interesting, let's add a few more imports. It's still processing. I wonder why it's taking so long, but let's wait. Maybe we made it loop. I think we might have made it loop. Yeah, we probably made it loop. Okay, well, I think we're almost out of time. So instead of trying to figure out where the bug is, I will leave that as kind of homework and wrap it up here with any questions before we run out of time.
Hi, I have a question. So when you set up the rules, you talked about rule dependencies. So does Shake take care that the rules don't create cycles? Because we are using stale, right? Like, so for example, for me to build the information for the get minimal imports, I need to build the rules, the other two rules, the type check rule and the GHCIDE rule.
Yeah, so the question is very good. Does Shake detect cycles in rules? And the answer is yes, it does. Shake has built-in rule cycle detector, which is quite annoying because, I mean, I've never come into a Shake cycle while working on GHCIDE IDE, but while using Shake as a standalone build system, that has happened to me quite a few times. And the error message is like, I found a cycle in this 200 rules or 200 rule invocations. So it's actually really difficult to find what the problem is, but it does detect them.
Okay, thank you.
Okay, any other questions? And if not, we are good to go.
Yeah, I do have a request though. Like, so will you be posting a version of this on the GitHub? Like, will you update your GitHub repo with the version of what we have so far?
Yeah, so what I'm going to do is I'm going to push this code to the MuniHac branch.
Okay.
In the Haskell github.com Haskell server, Haskell Language Server repo.
Okay, cool. Thank you.